Today we're going to see a very interesting topic, which is also an oral question, that is the relief valve versus safety valve. So we all know that relief valve is usually found on air bottles, heat exchangers, hydrophores, positive displacement pumps, sometimes in the fire line, freshwater generators if it is steam operated on the steam line, cargo tanks, and also you can find in certain, let's say, gas carriers, you have relief valve for venting out the cargo. You mean the gas. And safety valve, when I ask you where you can find it, you usually say that it is located in boiler, economizer, and superheater. You can interrelate these terms, that even you can say that a screw pump or a gear pump has a safety valve in it. It's right, both are similar, but technically there are some basic difference which we will see in this video. So first let's talk about the relief valve. As you all know, relief valve, let's assume that we have a relief valve on the air bottle, and the air bottle is supposed to operate at 30 bar, or the relief valve is set at a pressure of 30 bar. Now, when will the relief valve open or relieve the pressure? Now, the relief valve will lift only when the pressure is slightly above 30 bar. Let's say 30.1 bar. If the air bottle pressure reaches 30.1 bar, that is any small pressure above 30 bar, then the relief valve will open. So relief valve does not open at 30 bar. It opens at a pressure which is slightly above the set pressure. And the amount of opening, when you talk about the amount of opening of a relief valve, the relief valve does not open fully at 30.1 bar. At 30.1 bar, the relief valve opens, which is the opening is directly proportional to the increase in pressure. Which means, in other words, let's say the pressure of the air bottle is 35 bar. Depending on the design, the relief valve will now open fully. Now it's full open, but at 30.1 bar the relief valve is open, but it need not be fully open. It is slightly open and just relieving pressure which is sufficient to bring it back to operating pressure. So, to encapsulate it, a relief valve, or the amount of opening of the relief valve, is directly proportional to the increase in pressure. That's the point I want to derive with the relief valve first. One more point what you have to note with the relief valve is, again, let's say the relief valve is set at 30 bar pressure on an air bottle, and the pressure is 30.1 bar. The relief valve opens, but the amount of opening is proportional to 30.1 bar. It's slightly open just to relieve this 0.1 bar, which is excess of this 30 bar. If it is 35 bar, that is the pressure inside the bottle is 35 bar, the amount of opening is directly proportional to this excess pressure of 5 bar when compared to this safe operating pressure of 30 bar. So the opening is directly proportional to increase in pressure, and the opening is not all of a sudden. It's gradually opening, like let's say the air bottle reaches 30.1 bar, the opening is gradual. Gradual doesn't mean it is opening slowly. It is opening, and then as the 0.1 bar gets out of the air bottle, again it closes, again it opens. So it's intermittently opening and closing, or we can call it as feathering of relief valve. or just chattering of relief valve, just to opening and closing continuously, just to relieve this excess pressure. And as you all know, the relief valve is an ordinary spring-loaded valve. As you adjust the spring tension or the spring pressure, the pressure with which the relief valve opens is increased. Or as you increase the spring force, the pressure with which the relief valve opens also increases. Let's say I keep on tightening the spring pressure, and the relief valve opening pressure will increase from 30 bar to 35, 40, etc., etc. So I can adjust within the operating design of the relief valve from a range to the lower range to a higher range. That's how the manufacturer gives or designs the relief valve. And one important thing about relief valve is, as the relief valve opens, that doesn't create any immediate emergency or immediate need to attend the air compressor or the pump. Since it's opening, we are sure that nothing is going to happen wrong. So usually operating of a relief valve doesn't require immediate attention when compared to the safety valve. Alright, now let's see about the safety valve. Again, for this example, let's assume a boiler which is operating at 7 bar. Now, as we have seen that the relief valve doesn't open at the set pressure, it opens slightly above the set pressure. When we compare that with the safety valve when set at 7 bar for a boiler opens at 7 bar, or a safety valve opens at set pressure. Let's not talk about the 3% above the working pressure rule for the boiler. That's not the scope of this topic. So the safety valve lifts at the set pressure. Now, when we compare with the relief valve the amount of opening of the safety valve also has a spring and a valve enclosed in a valve housing, etc. But the amount of opening is huge. Whether it's 7 bar, 7.1, 7.5, whatever it is, the amount of opening is large, but it is not constant. The amount of opening is huge enough to create sufficient pressure drop within the pressure vessel. Alright, so as the safety valve opens at 7 bar in a boiler, it opens up and then it reaches or recedes only after creating sufficient pressure drop inside the boiler so that it can operate safely for, let's say, next some period of time. So it will probably reseat at 6.7 bar or something like that. As a thumb rule, we know that the safety valves should be set at 3% of the working pressure. That's the maximum setting. Working pressure plus 3%. That's it. Should be, the setting should be less than that. And or the exact rule states that the safety valve set pressure need not exceed, that's the term they use, need not exceed 3% above the working pressure. However, it recedes 4% below working pressure depending upon the design. So 4% below working pressure, let's say 7 bar is the working pressure, 4% below that is 6.72 or 6.6 bar roughly. So that's the pressure it recedes. So how it is done? There comes the function of lip. So we all know that the boiler safety valve has a lip, and this lip creates the extra lift so that there is enough pressure drop achieved when the safety valve lifts. Or the safety valve blowdown or the blowdown period is large when compared to the blowdown period of a relief valve. We can say it either this way, So we all know that one more stuff when we go in deep with the boiler safety valve, when we compare that with the improved high lift safety valve, has a waste steam piston. Apart from the lip, we have the waste steam piston. the lip creates the extra lift, and also the waste steam piston creates the extra lift, so that there is enough pressure drop and excess pressure is relieved 4% or 5% below the working pressure, and then the safety valve recedes. That's the major difference between the relief valve and the safety valve. So to encapsulate, both safety valve and relief valve are provided to safeguard either the equipment or the pipeline associated with it, or the environment, or of course for the safety of the people on board, and sometimes for the safety of the ship. So with that in mind, we have understood the difference between the relief valve and the safety valve.